Welcome back, everyone. Today, we're diving into a masterclass in preparation. I am super excited to guide you through this explainer on shotcrete inspection. Now, if there's literally just one golden rule you internalize before we even begin, it's got to be this. Successful shotcrete inspection begins in the office, way before a single drop of material ever hits the hose. You know, so many of those issues that look like field workmanship problems, they actually start way earlier. We're talking incomplete drawings, unreviewed mixtures, or unqualified personnel. We've all seen those disastrous jobs, right? The pump is roaring, the crew is sweating, and suddenly someone realizes, wait, the mix design wasn't actually approved for overhead work? That is a $30,000 mistake, and it started in a filing cabinet. So let's get our foundation rock solid so you never find yourself in that position.
Okay, let's look at our roadmap for today. We've got 6 parts: the documentation hierarchy, qualifying the crew, pre-construction alignment, some real-world field scenarios, QA versus QC roles, and finally our takeaways.
All right, Section 1, the documentation hierarchy.
This brings us to the foundational question every single inspector absolutely must answer before even walking up to a wall. What is required? It sounds so simple, doesn't it? But inspectors actually fail right out of the gate all the time because they just assume they know standard industry practices, rather than verifying the exact project specifications. Think about it. You can't effectively evaluate a placement, let alone enforce quality, if you don't actually know what the specific standard of success looks like for the job right in front of you.
So how exactly does this build? Well, project authority flows downward. It starts way at the top with the contract documents. Step 1. These establish the mandatory requirements for the entire project. Right below that, for Step 2, we have the drawings and specifications. The drawings tell us the geometry of the work, where the shotcrete goes, the reinforcement, the thickness, the embedments. And the specifications? They dictate the materials, testing, curing, and weather limitations. And hey, conflicts definitely happen. Like, what if a drawing shows a 4-inch thickness, but the specification manual requires a 6-inch minimum for this exact type of wall? You've got to know which document takes precedence before the nozzle man starts shooting. Finally, Step 3, we have the approved submittals. These connect those overarching design requirements to the contractor's specific proposed methods, things like their mixture info and personnel qualifications. So the really crucial point here, you don't create these requirements. Your job is to use this documentation hierarchy as your baseline to verify that the contractor is following the approved rules.
Moving right along to Section 2, qualifying the crew.
Now, if you're gearing up for your ACI Shotcrete Inspector exam, you need to pay close attention to this exam alert. The word representative is absolutely critical. A qualification panel, or mock-up, has literally zero value if it doesn't match the reality of the field. Its entire purpose is to prove that the proposed combination of mixture, equipment, crew, and placement procedure can produce acceptable shotcrete under representative conditions. Let's think about this for a second. If a nozzle man qualifies using a 2-inch hose in one specific mix, but on production day they roll up with a 3-inch hose, the velocity, the impact, the compaction of that shotcrete changes entirely. The original qualification is completely void because it's just no longer representative.
This comparison brilliantly illustrates the difference between an acceptable, realistic mock-up and a really risky, oversimplified one. Under good practice, we see a mock-up that actually mimics the structure, complete with 2 layers of closely spaced rebar, couplers, embeds, and difficult access. Under bad practice, we've got a simple single layer of widely spaced bars. Remember, the purpose of a qualification panel is not to create a perfect sample under super easy conditions. Not at all. It's to demonstrate the crew's ability to perform the actual difficult work. Why does this matter? Well, because heavily congested rebar can cause what we call shadowing or sand pockets. Those are hidden voids forming right behind the steel where the shotcrete didn't fully encase the bar. That complex mock-up on the good side is mandatory for proving the nozzle man can prevent those hidden structural voids out in the real world.
Okay, on to Section 3, pre-construction alignment.
Imagine you're exactly 1 hour away from pour time. You need to run through this rapid-fire checklist in your head to make sure the basic controls are in place. Are the drawings current? Is the specification known? Is the mixture approved? Are the personnel qualified? Does the equipment actually correspond to the procedure? Are the test panels ready? Have we set plans for curing and weather? And are repair procedures established? Take curing plans, for example. Why on earth is that on this list? Well, because high wind and heat can cause severe shrinkage cracking before you, the inspector, even leave the site. You definitely don't want to be answering these questions for the first time after a failed test. If these basic controls aren't firmly locked in during pre-construction meetings, your risk of quality problems just skyrockets.
All right, let's put this into practice with Section 4, real-world field scenarios.
Here is our first field problem.
Picture this. You're on site. The approved qualification was done with nozzleman A, but on production day, nozzleman B shows up and starts prepping the hose. The contractor just waves you off and says, "Hey, don't worry, he's certified too." I guarantee we've all heard this exact excuse on the job site. But is certification alone enough? What should you, the inspector, immediately verify?
The answer is absolutely no. Your immediate action is to verify the project qualifications. You halt the placement and check the approved submittal log. If nozzleman B isn't on it, they don't shoot, period. Why this matters is because shotcrete placement relies heavily on workmanship. A generic certification card might just mean the nozzleman is great at lightly reinforced vertical walls. It doesn't prove they have experience with this specific project's heavy congestion, thick sections, overhead placements, or complex geometry. So the correct question isn't, does he have a card? It's, does this person satisfy the qualification requirements for this specific work?
Let's look at field problem 2. You had a specific wet mix approved during pre-construction, but today is a scorching hot day. Hot weather means faster slump loss, and suppliers often try to overcompensate for that. So the supplier decides, right on the fly, to deliver a revised mixture. They throw in a different admixture combination, or maybe some extra water to make up for the heat. What should the inspector check here?
Your action here is to verify review and acceptance. I have literally heard stories of contractors trying to pass off a garden hose wet mix as approved just to keep the pump from plugging up. You just cannot allow that. Why it matters is that even if the concrete visually looks totally acceptable as it's coming out, unapproved mixture changes violate the contract documents. As the inspector, remember, you are not the engineer of record. You simply do not have the authority to bless a chemical change, even if you personally think it'll work. Your job is to verify that the paperwork matches the truck ticket. You've got to check if that specific on-the-fly change has been formally reviewed and accepted.
Okay, field problem 3. This one highlights a complete breakdown in planning. The crew is fully geared up, the trucks are waiting, the clock is ticking on the mix, and the hose is ready to shoot the wall. But you look around and notice the test panel forms aren't prepared, and the testing agency is nowhere to be found. What happens now? Your action is to hit the brakes and ensure testing requirements are ready. Why it matters is simple, but oh so critical. Testing procedures cannot be improvised after placement begins. You need to know exactly what will be tested, who is doing it, how frequently, and where those panels will be stored, all before production starts. The technical stakes here are massive, guys. If you let them shoot the wall without shooting the test panels simultaneously, you essentially have no legal, verifiable proof of the concrete's compressive strength. That could mean forcing the contractor to destructively core the finished structure later on. Ensuring these controls are in place mitigates some huge quality risks.
Let's jump to Section 5, QA versus QC roles.
This is where we clear up a massive source of job site confusion. Quality assurance and quality control are related, sure, but they are very different roles. Quality assurance, or QA, is associated with the owner or the owner's rep. This is often where the inspector sits, and it's all about verifying that the required quality is achieved. Quality control, or QC, is associated with the contractor. These are the physical actions taken to ensure the work actually meets the requirements. Let me give you a really vivid example. QC is the contractor calibrating the pump. QA is you, the inspector, verifying they use the right calibration method. If there's a void or defect in the wall, your QA role is to document it, but the second you grab a trowel and tell the crew how to patch it, you've just crossed into QC territory and you now own the liability for that fix. You must never assume authority you haven't been officially assigned.
And finally, Section 6, Final Takeaways. We've got 3 key takeaways today, and they carry a ton of weight when you're out there in the elements. Number 1, know the project documents before production starts. They are your absolute baseline for what success looks like. Number 2, qualifications must represent actual field conditions. Remember, a simple mock-up won't save a complex wall. And number 3, plan testing, curing, and repairs before shooting. Good field inspection is entirely dependent on good preparation.
I want to leave you with this field takeaway. It really should be your mantra on every single job site. Do not ask, does this look acceptable, until you first know, what does the project require? If you understand the approved materials, the personnel qualifications, and the testing plan before shooting starts, your field decisions will become incredibly clear.
So before you step onto your next site, ask yourself, are you truly verifying the work or are you just watching concrete dry? Something to think about. That brings us to the end of this deep dive. But our journey through the shotcrete inspection framework continues. Next time in Clip 3, we'll be tackling surface preparation in SSD. You definitely won't want to miss how that impacts the final structural bond. Until next time, stay focused, stay curious, and I'll catch you in the next explainer.